Now I want to discuss numbers. So numbers are classified into real numbers and imaginary numbers. What are real numbers? All the numbers except imaginary numbers are called real numbers. What are imaginary numbers? The numbers which does not exist are called imaginary numbers. Generally, we represent the imaginary numbers with the help of I. I is nothing but the root over minus 1. The value of root over minus 1 is undetermined. So the examples of imaginary numbers are 2i, 8i minus 3, etc. Rational numbers. So the numbers which can be written in the form of p by q are called as rational numbers. 3.5 bar, 0.3 bar, comma minus 4.3. For 3 bar we can write as 3 by 10, whose answer will be 1 by 333, and it is an irrational number. Now what are irrational numbers? Which are neither recurring nor are terminating, are called as irrational numbers. So the examples of irrational numbers are root over 11, root over 10, root over 3. Rational numbers are further classified into integers and non-integers. All the negative or positive numbers are known as integers. Those numbers which are not rounded are known as non-integers. Rounded in the sense which are not considered as part of decimal. Moreover, integers are further classified into negative integers, neutral integers, and positive integers. So suppose if you take a number like all the numbers for minus will be called as negative integers, and 0 will be a neutral integer, and all the numbers from plus 1 onwards will be known as positive integers. Now non-integers are further classified into decimals and fractions. In decimals we have two types, recurring decimals and non-recurring decimals. And for fraction we have proper fraction, improper fraction, and mixed fraction. If denominator is greater than numerator, it is called proper fraction. If denominator is lesser than numerator, it is called improper fraction. And mixed fraction is combination of both numbers and fraction. Let's discuss integers in detail. Integers are divided into even numbers and odd numbers. Integers which are divided by 2 and gives 0 as a remainder are known as even integers. Example for even integers is minus 10, 0, 2, 4, and so on. Odd integers. Integers divided by 2 gives 1 as a remainder are known as odd integers. Examples would be minus 3, minus 1, minus 5, and so on. Positive integers. So positive integers are classified into natural numbers and whole numbers. So natural number sequence starts from 1 and it goes like 1, 2, 3 and infinite. And whole number sequence starts with 0 and it goes like 0, 1, 2 and infinite. Whole number are also classified as neither prime nor composite. So neither prime nor composite numbers which are less than 2 are known as neither prime nor composite numbers. Example 0 and 1. 0 consists of only 0 and 1 consists of only 1. So 0 and 1 comes to the category of neither prime nor composite numbers. Prime numbers. The numbers which are exactly with two factors are called as prime numbers, and those two factors can be 1 and the number itself. The examples are 2, 3, 5. Now what are composite numbers? Numbers with more than two factors are known as composite numbers. Its examples are 4, 6 and 8. Now let's discuss prime number. They are further classified into even prime numbers, co-prime numbers and twin prime numbers. So even prime number means it is a combination of even and prime number. The only even prime number we have is 2. Now co-prime. Two numbers with only 1 as a common factor is known as co-prime number. So 14, 15 is a co-prime number, 2 and 3 is a co-prime number, 5 and 7 is a co-prime number. So co-prime number does not mean that the two number has to be only prime number or only odd number. So here 14 and 15 are not prime number, but here they are co-prime numbers because they are having 1 as a common factor. Twin prime. Now two numbers has to be prime numbers and the difference between those two numbers is 2. Then we call such type of numbers as twin prime numbers like 5 and 7. Now perfect numbers. Sum of all the factors equal to the number, then the number itself will be a perfect number. So if you take factors for a number and you add all the factors except the number, the sum should be equal to that number and that number will be called as perfect number. Example for the perfect number is 6. So we will say 6 is a perfect number. Fibonacci sequence. The sequence where you get your next number by adding two previous numbers is known as Fibonacci sequence. The example of this is 0, 1. If we take 0 plus 1, it will be 1, then 1 plus 1, it will be 2, then 1 plus 2, it will be 3, 2 plus 3 will be 5, and 5 plus 3 will be 8, and the series will go on. Next we are going to discuss the rule of BODMAS, like how we are going to get the 4 operations done. So BODMAS stands for B for bracket, O for off, D for division, M for multiplication, A for addition, and S for subtraction. And this is the exact order which we are going to follow while solving a question. Let's have an example. 45 divided by 5 into 3 bracket close minus 6 multiplied with 2 plus 5 minus 3 minus 2 bracket close. So here if you look at the order of BODMAS, so first you have to clear the brackets. So here if you look at the question, 5 into 3 lies in a bracket and 3 minus 2 is also enclosed in a bracket. So first we have cleared both these values. So 5 into 3 which is equals to 15 and 3 minus 2 is equals to 1. Next step which we are going to follow is division. So the division is 45 divided by 15. So 45 divided by 15 is 3 and next is multiplication. So it's 6 into 2, so we have to clear this first, which will be equals to 12. So 3 minus 12 plus 5 minus 1. So next I have to go for addition. So minus 12 plus 5 which is equals to minus 7. Now lastly I have to go for subtraction. So 3 minus 7 minus 1 is equals to minus 5. So whenever you are going to have different kind of operations, what you can do, you can follow this BODMAS rule. Now in order to convert your decimal number into a fraction, so if you see this example, convert to 326.87 to fraction, you see after decimal point there are two numbers. So in order to bring these two numbers to the value, we will multiply it and divide it with 100 and this will become 32687 divided by 100. Let's have another example. Convert 3.68 bar to fraction. Now whenever you want to convert a bar into a fraction, so after the bar you can see there are two numbers. So your task is try to make what the decimal point is available. So here in order to make your decimal part as 0, so if you take the given number like x is equals to 3.6868 bar, so the value of 100x is equals to 368.6868 bar. Now the value of 100x we already know, that is 368.6868 bar. Now if you subtract both the thing, if you observe, both the 100x and x has the same value, so 100x minus x comes to 99x, and 3.6868 minus 368.6868, the value comes as 365.0. So now you are able to make the decimal part as 0. So then your value of x is equals to 365 divided by 99. How to add and subtract some fraction numbers. Example, 3 by 5 minus 7 by 15 plus 9 by 10. So these are the three fractions. So here, whenever you are adding or subtracting in fraction, the first task is try to make your denominators equal. So here the good number for 5, 10, 15 is nothing but 30. So the first task here is to make all your denominators equal to 30. So 3 by 5 multiplied and divide with 6 by 6, and next 7 by 15 multiplied and divide with 2 by 2, and then 9 by 10 multiplied and divide by 3 by 3. So the value we get is 18 by 30 minus 14 by 30 plus 27 by 30. So now 30 is a common number, so take LCM of 30. So the denominator will be 30 and it will be like 18 minus 14 plus 27 divided by 30, which is equals to 31 by 30. Next we have how to multiply and divide in the fractions. So suppose if you want to divide and multiply 3 by 5 to 7 by 15. So here 3 and 15 you can directly cancel. 3 will be cancelled by 1 time and 15 by 5 times. So value will be 7 by 25. And similarly when you do the division, so 3 by 5 divided by 7 by 15, which is 3 by 5. Whenever you want to bring your denominator to the numerator, just reciprocate the values. So 3 by 5 multiplied with 15 by 7. So this will be 9 by 7. So whenever you are doing some division with fractions, just flip the denominators. Next, 3 by 5 divided by 7 by 1. So whenever the denominator consists of only one number, so you consider 7, which is equals to 7 by 1. And it is nothing but 3 by 5 multiplied with 1 by 7, which is nothing but 3 by 35. Conversions. So how to convert a proper fraction into mixed fraction, or mixed fraction to proper fraction. Suppose the number is 10 by 7. Whenever you want to convert, divide 10 with 7. 7 goes to 10 by 1, which is nothing but, you will get a remainder of 3. So this will be, start with your quotient. Quotient is 1, and then 3 will be your numerator, and then 7 will be your denominator, and the remainder, and then the dividend. So 1, 3 by 7 will go in this order. And this is nothing but your mixed fraction. And similarly, when you want to convert a mixed fraction into a proper fraction, like 1, 3 by 7, so multiply your denominator with the quotient, like 1, so this will become 7 ones are 7, and then add the numerator into it. This will become 10 by 7. So this is the way to convert mixed fraction to proper fraction. Next we have how to add and subtract in mixed fractions. Let's take a small example. Suppose 999 4 by 7 plus 999 3 by 5 plus 999 plus 999 2 by 5 plus 999 3 by 7. So what will be the sum of all these mixed fractions? So whenever you are adding or subtracting the mixed fraction, the best practice is add all the integers separately and add all the fractions separately. So here all 999 are integers. So there are 5 999. So the total sum of 999 will be 5 into 999 plus add all the fractions. Fractions will be 4 by 7 plus 3 by 5 plus 2 by 5 plus 3 by 7. 999 5 times is equals to 4995. And the sum of 4 by 7 and 3 by 7 is 7 by 7, which is equals to 1. And the sum of 3 by 5 and 2 by 5 is equals to 1. So 4995 plus 2 is equals to 4997. This is the way how to add or subtract mixed fraction. So next we'll discuss factors and multiples. So multiples are nothing but the number which we get after multiplying by integer values. Factors, the numbers what all we can multiply to get the number. It is nothing but the factor. So let us have another example. If you take 8 as a number, the factors for 8 are 1 is the factor, 2 is the factor, 4 is the factor and 8 is the factor. Because in what all tables you get 8 as a number which is nothing but a factor. And if you talk about multiples, then 8 is a multiple, 16 is a multiple, 24 is a multiple, 32 is a multiple. So in the table of 8, what all the numbers you get, they are nothing but multiples. Let us discuss the next topic, that is LCM and HCF. LCM. LCM means least common multiple. HCF, and that is highest common factor. We can also call HCF as GCD, which is nothing but greatest common divisor, and both are the same. Now, let's solve the first question. Let's know how to find the LCM. So let us find the LCM for 4, 6 and 8. Whenever you are finding your LCM, it is nothing but your least common multiple. The first thing which you can do is to write down multiples of the numbers. So let's see what are the multiples for 4. 4, 4 1s, 4, 4 2s, 8, 4 3s, 12, 4 4 16, 4 5s 20, 4 6 24, 4 8s 32 and up to you will go on till 40. And similarly for 6, 6, 12, 18, 24, 30, 36, 42 till 60. For 8, 8, 16, 24, 32, 40, 48 and so on. So now the first thing you have to do is in the least common multiple write all the multiples. So as the definition says least common multiple, so find all the multiples and after finding the multiples, select the common multiples among the three numbers. So among the given numbers, 24 is the common multiple and 48 is the common multiple. So 24 and 48 and 24 and 48. So these are the two common numbers in all the multiples. So the next step says least common multiple. So between 24 and 48, which is the least one? 24 is the least one. So you can say the LCM of the given numbers is 24. Now let's move on to the next one, that is HCF, highest common factor. So first thing which you have to do is to write down all the factors. After that you have to find what is the common factor. And then you are going to pick what is the highest common factor. Now what are the factors of 4? 1 is the factor, 2 is the factor and 4 is the factor. And similarly, what are the factors for 6? 1 is the factor, 2 is the factor, 3 is the factor and 6 is the factor. Now what are the factors for 8? 1 is the factor, 2 is the factor, 4 is the factor and 8 is the factor. So first you write all the factors and after writing the factors, pick the common factors. So here 1 is common and 2 is common, so 1 and 2 are the common factors for the given numbers. And between these we have to find the highest common factor. So the highest common factor is 2. Coming to the next one. That was the first way to find your LCM and HCF. And the second way to find your LCM and HCF is through factorization method. Now let us find the LCM and HCF of the numbers 32, 54 and 96. First we'll factorize 32. So 32 can be written as 2 multiplied with 16 and 16 can be written as 2 into 8 and 8 can be written as 2 into 4 and 4 can be written as 2 into 2, which means 32 is nothing but 2 into 2 into 2 into 2 into 2, which is nothing but 2 to the power of 5. Similarly, divide 54 as a prime factor. So 54 can be written as 2 into 27, 27 can be written as 3 into 9, 9 can be written as 3 into 3. So the total value of 54 is 2 into 3 into 3 into 3, which is equals to 2 into 3 to the power of 3. Finally come to 96, which can be written as 2 into 48. 48 can be written as 2 into 24. 24 can be written as 2 into 12, and 12 can be written as 2 into 6, and 6 can be written as 2 into 3. So when you multiply all these things, 96 can be written as 2 into 2 into 2 into 2 into 2 into 3, which is equals to 2 to the power of 5 and 3 to the power of 1. So now how to find your LCM and how to find your HCF. Now 32 is equals to 2 to the power of 5. So now 54 is written as 2 to the power of 1 and 3 to the power of 3, and 96 is written as 2 to the power of 5 and 3 to the power of 1. So whenever you are trying to find the LCM, so take the highest power of the values, and whenever you are finding the HCF, take the least power values and multiply the least powers. So 32 to the power of 5 is the highest value. Like, what is the highest power of 2? So it is nothing but 2 to the power of 5. So LCM will be 2 to the power of 5 multiplied with what is the highest power of 3? Highest power of 3 is 3. So your LCM will be 2 to the power of 5 multiplied with 3 to the power of 3. Now for finding the HCF, take the least powers. So what are the least powers among the given numbers? So 1 is the least power, so 2 to the power of 1. And what is the least power for 3? 3 to the power of 0, which is included with 32. So 0 is the least power. So HCF will be 2 to the power of 1 and 3 to the power of 0. Now there is one more way to find your HCF and LCM. So coming towards the third way, find the LCM and HCF of 32, 54 and 96. Now first write 32, 54, 96. For all these three numbers, the common number available is 2. So divide all these three numbers with 2. 2 goes for 32 16 times, for 54 27 times, and for 96 48 times. Now next number common available is 3. So 16 cannot be solved with 3, so write 16 as it is, and 27 goes 9 times with 3 and 16 times with 48. Now identify another common number, so that is 16. So 16 go for one time, and then 9 will remain same, and then again 16 for one time. Next the common number will be 9, so 1 will remain same, 9 goes for 9 one times, and then 1. So when you are going for the LCM, you will multiply all the numbers which you have considered for this LCM. So your LCM will be 2 into 3 into 16 into 9 into 1 into 1 into 1. Now whenever you want to find your HCF, pick any two numbers from 32, 54 and 96. So for time being, I have considered 32 and 54. 32 go for one time. Now we are left with the remainder 22, and bring this 32 for the next division. 22 go for one time, so 22. So 32 minus 22 is 10. So previous number was 22, so bring 22 down here. 10 goes for 2 times, so you get 20. Now you get 2 as the remainder. Now bring your 10 to the next place, and 2 will go 5 times for 10. Now you will get the remainder as 0. The HCF of 32 and 54 is nothing but 2. With this result, you can also find the HCF for the next number. So the left out number is 96. Now 2 and 96, so 96 goes for 48 times, so it will be 96 minus 96, so 0. Now the HCF for 32, 54 and 96 is 2 because 2 is the number what is left out before you get 0 as the remainder. Before getting 0, whatever number you are dividing is nothing but is your HCF. Now some points to be noted while you are doing your LCM and HCF sums. So whenever there are two numbers, the LCM of A and B multiplied with HCF of A and B is equals to A into B. If you want to find the LCM of X by A, Y by B and Z by C, it is nothing but LCM of XYZ divided by HCF of ABC. So whenever you want to find the LCM of a fraction, it is nothing but a LCM of numerator divided by the HCF of denominator. And similarly, when you are trying to find out the HCF of fractions, so HCF of numerator divided by the LCM of numerator. So that's why HCF of XYZ divided by LCM of ABC. Now if the number have been represented as A to the power of X, B to the power of Y and C to the power of Z, where A, B, C are the least prime factors, Then if you want to find the total number of factors, then it will be x plus 1 into y plus 1 into z plus 1, and sum of the factors will be equal to the a to the power of x plus 1 minus 1 divided by a minus 1 multiplied with b to the power of y plus 1 minus 1 divided by b minus 1 multiplied with c to the power of z plus 1 minus 1 divided by c minus 1. So let us see a small example now. Find the sum of factors and the number of factors for 480. Now when you are finding the sum of factors and number of factors, the first thing which you have to do is divide the given number into the prime factors. So 480 can be written as 200 and 240. 240 can be written as 2 into 120, 120 can be written as 2 into 60, 60 can be written as 2 into 30, 30 can be written as 2 into 15, and finally 15 can be written as 3 into 5. So the product of all the prime factors is nothing but 2 into 2 into 2 into 2 into 2 into 3 into 5, that is 2 to the power of 5, 3 to the power of 1 into 5 to the power of 1. So here now if you want to find the total number of factors for the given number, so it will be equals to, so power plus 1 multiplied with power plus 1 multiplied with power plus 1. So 5 plus 1 it is 6, 1 plus 1 it is 2, and 1 plus 1 it is 2. So total number of factors is 6 into 2 into 2, which is nothing but 24 factors. And now when you are going to find the sum of the factors after dividing, so sum of factors will be 2 to the power of 5 plus 1 minus 1 divided by 2 minus 1 multiplied with 3, 1 plus 1 minus 1 divided with 3 minus 1 multiplied with 5, 1 plus 1 minus 1 multiplied with 5 minus 1 divided by 5 minus 1. So which is equals to 2 to the power of 6 minus 1 divided by 1 multiplied with 3 to the power of 2 minus 1 divided by 2 multiplied with 5 to the power of 2 minus 1 divided by 4, which is equals to 64 minus 1 divided by 1 into 9 minus 1 divided by 2 into 25 minus 1 divided by 4, and that is equal to 63 divided by 1 into 8 divided by 2 into 24 divided by 4. If you do all the cancellation, the final value you will get is 1512. So this is the way how you can find the sum of total number of factors. Finding the maximum power in a factorial number. Now here the question says find the number of zeros in 20 factorial. So now 20 factorial can be written as 20 into 19 into 18 into 17 and so on up to 3 into 2 into 1. Now in order to get a 0, we need to find out that how many 2's are available in the factorial number and how many 5's are available in this factorial number. Now what we can do is, like 2 is available in each and every number. Now here we will identify how many 5's are available. Now no need to check for 2 because in all even numbers you get 2, so count for total numbers of 5's. So here whenever you write the 20 factorial, you get 5's at the following places, and those places are 5, 10, 15 and 20. So these are the 4 places where you get the 5. So you can say 4 zeros will be available in 20's factorial. Now next we have find the number of zeros in 100 factorial. So here the task is write down all the numbers where you get the 5. So when you get 2, obviously the product will be 10. So now the places where you will get 5 is 5, 10, are 5, 10, 15, 20, 25, 30, 35, 40, 45, 50, 55, 60, 65, 70, 75, 80, 85, 90, 95 and 100. So these are all the places where you will get 5 as a number. So here are the 20 numbers where we get the 5. Now there are some particular numbers where you will get 2 5's, like 25 is a number where you will get 2 5's like 5 into 5, and then 50 is a number where you will get 2 5's like 5 into 5 into 2, then 75 is a number where you will get 2 5 like 5 into 5 into 3, and then 100 is the number where you will get 2 5's like 5 into 5 into 4. So totally you will get 4 extra 5's. So total number of zeros will be 20 plus 4, which is equals to 24. Now find the number of zeros in 1000 factorial. When number goes up, it will be tough to count the numbers manually. So the one thing which you can do is divide 1000 by 5. So it will go for 200 times. Again divide, it will go for 40 times. then one more time it will go for 8 times, and lastly by 1 time. So now add all numbers and the total number you will get is 249. Now you can say there will be 249 0 in the 1000 factorial. So this is one of the easiest way to find the factorial in any number, which is nothing but a continuous division of the number. Next we have find the maximum power of 6 in 100 factorial. Now to get a 6 we need two numbers. One number is 2 and the other number is 3. So first try to find number of 2's in 100 factorial. So as we have already discussed, if you want to find a particular number in a factorial, you will go for the continuous division. So in order to find the number of 2 in 100 factorial, divide 100 with 2. So it goes for 50 times, then it goes for 25 times, then it goes for 12 times, and 6 times, and 3 times, and 1 times, and then add all these numbers. 20 plus 25 plus 12 plus 6 plus 3 plus 1, which is equals to 97. Now similarly, as we want to find the number of 3, so we will divide it with 100. So 3 go for 33 times, then 11 times, then 9 times, 3 times, and then 1. And when you will add all these 3, it will be 48. So in your 100 factorial, I can say the highest power will be 2 because it comes 97 times, multiplied with 3 to the power of 48, multiplied with some other m value. So if you take both these things, so can I write the maximum power of 6? Even there are 97 2's, but the maximum power is 3 to the power of 48. So total value will be 6 to the power of 48. So here we get 48 6's in 100 factorial. And this is the highest power of 6 in 100 factorial. Suppose if you want to check if a number is divisible by 2, so the last number should be divisible by 2. If you want to check if a number is divisible by 4, like 4 is nothing but 2 to the power of 4, then it will be last two numbers should be divisible by 4. And next, divisible to the rule of 8, it can be written as 2 to the power of 3. Here last three numbers should be divisible by 8. Similarly, if you want to check whether a number is divisible by 3, so sum of the digits in the number should be divisible by 3. And similarly, if you want to check with 9, 9 is nothing but 3 square. Sum of the number in the digits should be divisible by 3. So sum of the digits in the number should be divisible by 9 and 5. So if the last digit in the number is 0 or 5, then the number is divisible by 5. 10. When last digit in a number should be 0, then you are able to divide it with 10. Then 6. Any number which you can verify with 2 and 3. Next, the divisible of 12. The numbers you should check with the divisible of 3 and 4. And if you want to check the divisibility of 11, so it is nothing but the difference between the sum of the odd numbers digits and the sum of the even number digits from right to left should be 0. So those are divisible by 11. So if you write the number and if you find some of the alternate of the numbers from left to right and the difference between them and their sum should be equal to 0 or it should be a multiple of 11, then it can be easily divisible with 11. So now how to check the divisibility rule for 7? Double the last number and subtract from the previous number or previous digit continuously. If the left out digit is divisible by 7, then the entire number is divisible by 7. Otherwise it is not divisible by 7. So let us take a number and let us check the divisibility of all the possible numbers. 3, 4, 6, 8, 5. So first we will check it with 2. Sum of all number till you get a single digit. For 2, take the last digit. Last digit is 5. Is 5 divisible by 2? No. No, 5 is not divisible by 2, so this number is not divisible by 2. For 3, sum of the numbers. So here the sum of the numbers is 26. 26 is not divisible by 3. So the entire number is not divisible by 3. So let's buy 4. Last two numbers. So the last two numbers are 85. Is 85 divisible by 4? No. So the entire number is not divisible by 4. Next with 5. So the last digit is 5. Is the number divisible by 5? Yes, the number is divisible by 5. Next with 6. If you want to check with 6, So you have to satisfy it with 2 and 3, but number is not satisfied with 2 as well as 3, so the number is not divisible by 6. So next is the divisibility rule of 7. Double the last numbers and multiply it with the previous number. So among 3, 4, 6, 8, 5 is the last digit, so double the 5, it will be 10. Subtract it from previous, so you will get a number 3, 4, 5, 8, and again double the last, so 8 into 2 it will be 16. Subtract from the previous number, minus 16, so it will be 329. Again double the last number, which is 9 into 2, again 18, and subtract the 18 from 32, so it will be 14. So the left out number is 14. Is 14 divisible by 7? Yes, the number is divisible by 7, so you can say the total number is divisible by 7. Next, divisible by 8. If you want to check the divisibility, last 3 numbers should be divisible by 8. Last 3 numbers are 6, 8, 5. So 6 at 5 is not divisible by 8. So the entire number is not divisible by 8. Divisibility of 9. So sum of the number should be divisible by 9. So 3 plus 4 plus 6 plus 8 plus 5, which is equal to 26, and it is not divisible by 9. So the entire number is not divisible by 9. Next for 10. So the last digit should be 0. Here it is not 0. 11 alternate to the sum of digits. So here 3, 4, 6, 8, 5. So 3 plus 6 plus 5 minus 4 plus 8, which is equals to 14 minus 12, and that is 2. So 2 is not divisible by 11, so the entire number is not divisible by 11. Next for 12. In order to check the divisibility with 12, you have to check for 3 and 4. So if you take the number we have already tried with 3 and it is not divisible by 8, so you can say the total number is not divisible by 12.